Hey everybody, this is Larry. This is day 5 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Let's see if there, nope, no extra points. Alright, today's problem is combination sum 4. Given an array of distinct integers nums and a target integer target, return the number possible combination that add to target. Okay, so this is what you might call it. One of those variations of knapsack. Negative numbers don't really matter that much. It's just you have to. I mean, you could either use a map or just something that actually it's kind of funny because I do remember the negative number version being one of my earlier competitive programming things. And in those days, and this will age me a lot. In those days, there were no maps or dictionaries, if you will, in a lot of the standard libraries. Meaning that in C++, imagine if you cannot use, STL, right? And I think Java always had it, but in C++, and so forth, right? Or C, if you will, C or C++. I mean, I know that there's a hash table C implementation, but it was always way clunky to use, so I don't know that counted. And so, to be honest, for a while, and if you I think some of my earlier videos from a few years ago, it shows this up. And what I mean by that is that I was really bad at those dictionary-based dynamic programming solutions because there was no dictionaries back then, and I was always like, how do you solve this? And then of course I even an old dog can learn a few tricks once in a while, and I did finally learn dictionary-based dynamic programming for a few things. But that's going to be so that's how you solve the negative number in any case. Unless I misread it. But yeah. Yeah, there's gonna be less than the answer is gonna be that, but yeah, and because you can choose any number at any instant, then all you have to do is just it's going to be dynamic programming, but based on target, right? And I'm going to do it recursively because I think recursive is I think historically when I was younger I did not do it recursively, but now I'm just going to do it because it's easier to explain, because it's easier to reason, right? Which means that, okay, let's just say get the answer, get sum for some target, right? And then it is literally, if target is equal to 0, we return 1, or get count, maybe it's a little bit more different. And then if target is less than 0, we return 0, and yeah, and then we'll do the caching later, but basically the idea is that, okay, for x in nums, and they're unique, which is fine, but let's see, if x is greater than or equal to target, or the other way around, right? Yeah, whoops. Then say total is equal to 0. Total we increment by get the count of target minus x, and then we just return total, and then we just return get count of target, and that's it. Yeah, because we don't need to reuse, or we can reuse it in a weird way. This is going to be good just because of that. And what I mean by that is that we don't have to keep track of index because we don't have to keep track of the one, like we don't have to dedupe in any way, which is basically at any smaller number, we just keep on going smaller as we can. Cool. Yeah, let's see. So of course this is going to be too slow. We can try something really obvious. I mean, if you do 1 and 2, I was going to say maybe that's Fibonacci, but is it Fibonacci if we just do 1 and 2? Right, because then and then you just do 1,000. Anyway, it'll probably be too slow. Don't know if it's Fibonacci. Yeah, the answer is too big, so it's an invalid test case. But you can imagine that we are a little bit better about it, it will be too slow. So the idea to fix this is just with memorization. Memorization is noticing the input to target. If we look at here, the target will be all less than 1,000. So, and of course that would have TLE anyway, but it just, you know, got blocked by data checker, so it didn't even really run. But yeah. And then, you know, a possible thing is saying that answer is equals to, okay, the way that I usually write it is we have a cache. Well, the way that we usually write it, we spell cache correctly. And we have, just say like negative or none times target plus 1. And then just has cache, you know, is equal to force times target plus 1, right? And this is, why does this work? This is because target can only go from 0, well, this target, which is, I guess, confusing, to this bigger target upwards, say, right? And that's pretty much it, right? Because for every possible, or for every input that you put into this function, you always get the same answer. And that's why we can save it down. We can be like, oh, we know the answer to this one already. So why don't we, you know, if we already know the answer to this one, then, then why don't we just return it directly, right? So that's the idea. And one thing that maybe sometimes I forget to call it out explicitly, though it should be, I mean, I don't know if it's obvious, but it is something that, that you do have to call it out explicitly, is that in order for this to work, it has to be acyclic, right? There cannot be any cycles. And what I mean by that is, actually, I didn't read the extra, there you go, yay. So negative numbers is okay. 0 is the one that is a little bit tricky, right? Because if there's zero numbers, then yeah, I guess that's another thing. But if there's if numbers 0, then you could just have infinity for obvious reasons. You could just add zeros everywhere. Negative numbers, we also may have some possibilities of, you know, infinities. So we have to consider that as well. I don't know how you want to do it, but there are a couple of ways you can do it. But yeah, but conceptually, because I think the first time I read it, you know, maybe it could be, you know, the number of ways to do it with k numbers or something like this, right? That could be one constraint. Then negative numbers don't really matter, or if they, you know, you may have to change the possible inputs and stuff like this. But that's the general idea. Cool. What's the complexity here? That's going to be, well, let's go, right? Let's count. So the number of possible, this is actually a different one. So yeah. So total time complexity is just equal to time per test case, or per input case, times number of input case, right? That should be straightforward. And number of input is equal to O of target, as we said, so O of t. And each input takes O of n times, you know, because we have this for loop. So in total, this is going to be O of t times n, or target times n, and this is pseudo polynomial as a result. In terms of space, this is going to be O of t. You could, you know, this is O of one space per input. So yeah. That's pretty much all I have for this one. So let me know what you think. Let me know if you missed anything. Let me know if I can explain anything better. As usual, I will do an extra bonus question. So, you know, hit the subscribe button and make sure you follow that if you want to do an extra one with me. If this was too easy for you, or if this was too hard for you and you just want to try another one, you know, let's do it together. Keep that streak alive. That's all I have. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.